Hello everyone, this is Javed and it is my lesson number 4 about number system, and today the topic is properties of equalities. So let's start with reflexive property. Reflexive property. This property says that if we have a number a, then a is equal to a, means a number can only be equal to itself. For example, 4 is always equal to 4, 7 is always equal to 7. Okay, we can never say that 4 is equal to 20. This is wrong. Also, we can never say that 7 is equal to 15. This is wrong. Okay, so reflexive property says that a number can only be equal to itself. The next property is symmetric property. This property says that if a number a is equal to b, then obviously b is equal to a. This property helps us a lot while we are solving some equations. For example, here we have an equation 5x minus 4 is equal to 7x minus 10, and we want to solve this equation for x. So when we continue solving it, then we reach a stage where we get this, that 3 is equal to x. 3 is equal to x. This does not make any sense. But if we use the symmetric property, we can write it as x is equal to 3, and this makes sense. So this is how the symmetric property helps us to solve the equations. The next one is additive property. This property says that if a is equal to b and we have a number c, and we can add the number c on both sides to get a plus c is equal to b plus c. This is a very interesting property of equality which we mostly use while we are solving the equations. Now we will solve some equations by using the additive property. X plus 7 is equal to 4, and we want to solve this equation for x. We want to get the value of x. So we will have to remove 7 so that we can get the equation in the form of x. 7, we want to remove 7, so we will have to add the additive inverse of 7 on both sides, and the additive inverse of 7 is minus 7. So we can write it as x plus 7 plus minus 7 is equal to 4 plus minus 7. So when we will solve this, it becomes x plus 0, because 7 plus minus 7, these are additive inverse, and the answer will be 0. And it is equal to 4 plus minus 7, this is equal to minus 3. X plus 0, here 0 is the additive identity which I have discussed in my last video, that if we add 0 in any number, we get that number. So x plus 0 is also equal to x, and this is equal to minus 3. This is our solution. The next example is x minus 10 is equal to 5, and we want to solve this equation for x. So we will have to remove minus 10 from here. The additive inverse of minus 10 is plus 10, so we have to add plus 10 on both sides of equation. X minus 10 plus 10 is equal to 5 plus 10. Minus 10 plus 10, these are additive inverse, so x minus 0 is equal to 50. So we can write it as x is equal to 15. The next one is 5 plus x is equal to 0, and we also want to solve this equation for x. So the additive inverse of 5 is minus 5. Minus 5 plus 5 plus x is equal to 0. Minus 5 plus 5, additive inverse, so 0 plus x is equal, sorry, I forgot to add 5 here, minus 5. Minus 5 plus 5 plus x is equal to 0 plus minus 5. we have added minus 5 on both sides, this one and this one. So minus 5 plus 5 0 plus x is equal to minus 5. We can also write it as x is equal to minus 5, and this is our solution. So we can see that how easily we have solved these three examples, this one, and this one, by the use of additive property of equalities. The next one is multiplicative property. So this property says that if a is equal to b and we multiply a number c with both, then we can write it as a times c is equal to b times c. Let's solve some example by using this property. The next example is 2x is equal to 10. 2x is equal to 10. We want to solve it for x, so we have to remove 2 from the left side of equation, and we can only remove 2 by multiplying it with its reciprocal. So the reciprocal of 2 is 1 by 2. 2x, we will multiply 1 by 2 on both sides, then multiply by 1 by 2. So 1 by 2 and 2, these are reciprocal, so these will cancel out, and x is equal to 10 by 2, which is equal to 5. This is our solution. The next one is minus x is equal to 17. Minus x, we can also write it as minus 1 dot x is equal to 17. We want to remove minus 1 from here, so we will have to multiply with its reciprocal, which is also equal to minus 1. So minus 1 multiplied by minus 1 multiplied by x is equal to minus 1 multiplied by 17. So minus 1 multiplied by minus 1, we will get 1. 1x is equal to minus 1 multiplied by 17 minus 17, and we can write 1x as simply x, which is equal to minus 17, and this is our solution. The next one is 1 by 3rd x is equal to 8. Here we want to solve it for x, so we have to remove 1 by 3 from left side, and we can only do this by multiplying both sides by the reciprocal of 1 by 3, which is 3. 3 multiplied by 1 by 3, x is equal to 8 multiplied by 3. So x is equal to 24, and this is our solution. So here we can see that by using multiplicative property, we have solved these three equations very easily. The next property of equalities is transitive property. This property says that if a is equal to b and b is equal to c, then a is equal to c. Let's try to explore the idea with the help of an example. If we have these two equations, 2 minus 3x plus 2 is equal to 5y, and 5y is equal to 7, and we want to solve these two equations for x. So here we can assume that this is equal to a, this is equal to b, same 5y, so this is also equal to b, and this is c. Okay, so by using the transitive property, we can say that here b is common, 5y and 5y, so we can directly write minus 3x plus 2 is equal to 7. A is equal to c, minus 3x plus 2 is equal to 7, and then we can further solve it for x. But if we don't use the transitive property, then we will have to find out the value of y. 5y is equal to 7, so we want to remove 5 from here. We will multiply it with its reciprocal, which is 1 by 5. Also here multiply by 1 by 5, and we will get y is equal to 7 by 5. Then we will add this value here, means minus 3x plus 2 is equal to 5, and the value of y is 7 by 5, minus 3x plus 2 is equal to 5, we'll cancel this, is equal to 7. So we here you can see we need to do some steps to reach at this stage, but with the help of transitive property we do not need to solve these steps, and we can directly reach at this stage, and then we can solve it for the value of x. So this is how the transitive property help us to solve the equations. So let's try to solve some examples by using the properties of equalities. Here we can see 11 is equal to 2 by third x plus 7, and we want to solve it for x. So we have to remove 7 and 2 by third from right side, okay, and we will do this step by step. First we will remove 7 by adding the additive inverse of 7 on both sides. Minus 7 plus 11 is equal to 2 by 3x plus 7 plus minus 7, and we will get 4 is equal to 2 by 3x plus 0. 4 is equal to 2 by 3x, okay. And now we want to remove 2 by 3, so we will multiply with its reciprocal, which is 3 by 2. 3 by 2 dot 4 is equal to 3 by 2 dot 2 by 3x. These are cancelled. Here we will get x, and here we will get 3 4 times 12. 12 divided by 2, 6. 6 is equal to x, and we can also write it as x is equal to 6. This is our solution. The next example is 4x minus 6 is equal to 14. So we can solve it as 4x minus 6 plus 6 is equal to 14 plus 6. These are cancelled, so 4x is equal to 20. Then we will multiply the both sides with the reciprocal of 4, which is 1 by 4. 4x is equal to 20 multiplied by 1 by 4. So x is equal to 5. So you can see that by using the properties of equalities, how easily we have solved our equations. So this was all about the properties of equalities.